we're gonna talk quickly about our project. So this is the UML use case diagram. So first, with the speakers around HANA, when I say the diarization model will determines who speaks what, and then it will convert a speech to text, and then it goes to conversation model. Then it will generate the responses to the specific speech by the speakers. And then if HANA sees that one of the responses is a valid response, she'll choose it, or she'll manually type it. And here's the flow diagram for diarizations. Then this is the sequence diagram and the architecture. And next, we revised the code to make it more Pythonic and more productive. For example, instead of creating a loop here that has two elements each, for example them and hello, we're gonna add text like this. So with just one line of code, we got a result of the same here.
For creating the diarization API, we first created a class that is a diarization class that, when initialized, loads the model from Hugging Face, and then has a function for run diarization where it does any pre-processing that we want or formatting of the data. We run diarization, and then all the post-processing and how we format the data once we have the diarized data. On the right side, you can see on the bottom, we also added a new API to the Fast API code. And then on the top there, you can see that it's a post to transcribe from audio, where you can send in a file, an audio file, and then the run diarization function is called on it. We noticed that running locally, we are now running 4 models, actually 5. 3 large language models, the one diarization model, and then a transcribing model. This becomes very heavy, especially since model is large and needs to be uploaded to RAM. And so it would be better to be able to run this on GPU. So we moved the code so that a Google Colab notebook can take in the code and run it. And so the Google Colab is our API. We just had to expose it to the internet using ngrok. And then the API ran a lot faster. It was about a 50 times speed increase. To demo our current progress, I will start out by going over or just showing that we've created this Google Colab that updates Python because needed the latest version, sets up ngrok, which opens up in a server to the internet, and then clones our repository from the specific branch that we want, and then runs the app. When it runs the app, ngrok over here creates a tunnel for an open IP address or an open HTTP address that redirects to Google Colab's local host, and then that's where the API is running. And so any request we make to this address that they have here ends up inside our Google Colab. And then here we created this new API called transcribe from audio. Before we had the suggest next word and the suggest from response. This transcribe from audio takes in a audio file. So for example, we will try with this audio file, which has multiple people talking in a row. When I click execute, we can see over here that the post was made. Where is it at? There it is. Post transcribe from audio call was made. It ran the diarization and it split the audio into different start and stop times. And then what it also did is it created a folder here with diarization where it has all of the audio split out by those times. So you can see speaker 0 or speaker 1 initially spoke here, and then speaker 0 spoke, and then spoke again, and then speaker 1 spoke, and then speaker 0 spoke. And this is according to the audio, which can be demoed later once the UI is built out. Now that we have the API running on Google Colab and the Diarization API set up, we have to integrate it with the UI, and we're getting some issues with that right now with how we're sending the audio data and reading it in. And then after that, we need to update the UI and the other models so that they work with multi-person conversations. And then if time permits, we're also going to try some other diarization models. And if more time permits, we might even try TensorFlow, JS, gesture tracking.